Welcome to the eighth part of VCAA Mathematics 2020 exam paper series. In this video, we will present exam paper 2, section B, question 1, which consists of 6 parts. Most students had done well on part A, part B, part C, subpart 1, part D, as well as all the subparts of part E. However, most students scored poorly on part F. In this video, we will go through all the parts of question 1 in detail.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Mathematics exam paper series. This is section B of 2020 exam 2 paper. There are total 5 extended response questions in section B. In this video, I will present you the first question. The first question in section B is a quadratic function f of x equals a multiplies x plus 2 or in parentheses squared multiplies x minus 2 or in parentheses squared, along with its graph where a is a real number and the domain of the function is R, the whole real number. There are 6 parts in this question. Part A is to show that a equals 1 over 4. Part B is to express f of x equals 1 over 4 multiplies x plus 2 or in parentheses squared multiplies x minus 2 or in parentheses squared in the form of f of x equals x to the 4th over 4 plus bx squared plus c, where b and c are integers. Based on the graph of its derivative as shown here, part C has 2 subparts. Subpart 1 is to write the rule of its derivative function in terms of x. Subpart 2 is to find the minimum value of its derivative on the open interval from 0 to 2. Here we continue to read out first question of section B. Now we let the function h of x equals negative 1 over 4 multiplies x plus 2 or in parentheses squared multiplies x minus 2 or in parentheses squared plus 2, along with the parts of the graphs of f of x and h of x. Part D is to write a sequence of 2 transformations that map the graph of f of x onto the graph of h of x. Part E has 3 subparts, where the first subpart is to state the value of x for which the graphs of f of x and h of x intersect. Subpart 2 of part E is to write down a definite integral that will give the total area of the shaded region in the graph. Subpart 3 of part E is to find the total area of the shaded region in the graph. In part F of this question, if D is the vertical distance between the graphs of f of x and h of x, the question here is to find all the values of x for which D is at most 2 units. Now we start to solve part A of the first question in section B. Since part A is to show that a equals 1 over 4, and based on the given y-intercepts at the coordinates 0, 4, f of 0 equals 4. Hence, a multiplies 0 plus 2, or in parentheses squared, multiplies 0 minus 2, or in parentheses squared, equals 4. Solving this equation, we obtain the value of a, which is 1 over 4. Part B here is to expand the function f of x. As it can be seen, the formulas of complete square as well as the difference of 2 squares are used to do the expansion. Now, based on the graph of the derivative function as shown on the right. Part C has three subparts. Subpart 1 is to find the rule of this derivative function, which can be achieved by differentiating the results from part B. So f prime of x equals 3x cubed minus 4x. Since subpart 2 is to find the minimum value of f prime of x on the open interval from 0 to 2, we here differentiate f prime of x again to find its second derivative, f double prime of x, and then equate to 0, which gives x equals plus or minus 2 over square root of 3. However, according to the given interval, we only take x equals 2 over square root 3. So the minimum value of f prime of x equals 2 over square root 3, or in parentheses cubed minus 4 times 2 over square root of 3, which equals negative 16 square root 3 over 9. Now we let another function h of x, which equals negative 1 over 4, multiplies x plus 2 all in parentheses squared multiplies x minus 2 all in parentheses squared plus 2. And the part of the graphs of f of x and h of x are shown. Based on the functions of f of x and h of x, as well as their graphs, part D is to show a sequence of two transformations that map the graph of f of x onto the graph of h of x. According to the rules of f of x and h of x, the first step of transformation is to reflect f of x in x-axis. So the rule becomes negative 1 over 4 multiplies x plus 2 all in parentheses squared multiplies x minus 2 all in parentheses squared. Then the second step is to translate the function 2 units upwards. So it becomes negative 1 over 4 multiplies x plus 2 all in parentheses squared multiplies x minus 2 all in parentheses squared plus 2. Part E has two subparts. Subpart 1 is to find the x values of the intersection of f of x and h of x. So we set f of x equals h of x. Hence, 1 over 4 multiplies x plus 2 all in parentheses squared multiplies x minus 2 all in parentheses squared equals negative 1 over 4 multiplies x plus 2 all in parentheses squared multiplies x minus 2 all in parentheses squared plus 2. The equation is then rearranged to x squared minus 4 all in parentheses squared minus 2 squared equals 0. Solving this equation, we obtain the values of x are plus or minus square root 2 or plus or minus square root 6. According to the diagram, subpart 2 is to find the shaded area. So the area is expressed as the integral from negative square root 6 to negative square root 2 of h of x minus f of x, or in parentheses with respect to x, plus the integral from square root 2 to square root 6 of f of x minus h of x, or in parentheses with respect to x. Due to the symmetry of the graph, the area is simplified to 2 multiplies the integral from square root 2 to square root 6 of negative 1 over 2 multiplies x plus 2 all in parentheses squared multiplies x minus 2 all in parentheses squared plus 2 all in parentheses with respect to x. Subpart 3 of part E is to evaluate the area based on the expression from subpart 2. With the help of the CAS graphic calculator, the area can be calculated, which equals 2.72 units square. In part F of this question, we let D be the vertical distance between the graphs of f of x and h of x. To find all values of x for which d is at most 2 units, we need to look at both inside and outside of the shaded area. Since the maximum of d inside the shaded area is just 2, we only need to look at the outside of the shaded area to find the values of x1 and x2 as indicated in the graph. So we establish the equation f of x minus h of x equals 2, which can be written to 1 over 2 multiplies x plus 2, or in parentheses squared, multiplies x minus 2, or in parentheses squared, minus 2 equals 2. The equation is then factorized and simplified to x squared minus 4 plus 2 square root 2, or in parentheses, multiplies x squared minus 4 minus 2 square root 2, or in parentheses, equals 0. Hence, applying the null factor law, we obtained that x equals plus or minus square root of the result of 4 minus 2 square root 2, or x equals plus or minus square root of the result of 4 plus 2 square root 2. As indicated, both x1 equals square root of the result of 4 minus 2 square root 2 and x2 equals square root of the result of 4 plus 2 square root 2, as they can be seen from the graph. Considering the symmetric property of the graph as well as the shaded area, the x value range that satisfying d is less than or equal to 2 are within two closed intervals. One is from negative square root of the result of 4 plus 2 square root 2 to negative square root of the result of 4 minus 2 square root 2. And the other interval is from square root of the result of 4 minus 2 square root 2 to square root of the result of 4 plus 2 square root 2. Alternatively, the intervals can be expressed in their decimal forms, as shown on the screen.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.